Namaskaram. Good evening, student. 12th physics. In our last class, we have discussed open organ pipe and closed organ pipe. Stationary waves formed whenever same frequency, same amplitude waves interacting in that target and reflected waves forms. Once the reflected wave and the incoming wave interfere or superimpose, there will be a new pattern, new wave that called as stationary wave or standing wave. So, how the stationary or standing waves produced in the open organ pipe and closed organ pipe? What are the frequency relations? That is first harmonic, second harmonic. Already we have discussed it in that last class. Today we are going to the Doppler effects. Okay, this is a 8 mark question and which is belongs to waves unit. 12th physics waves units. Okay, right. Often, we have noticed that siren sound coming from police vehicle or ambulance increases when it comes closer to us. Yeah, whenever vehicle comes to us, there will be a increasing in that sound. Here I am, me. Sound coming. That bus or bike coming towards to me. Okay, so there will be a increasing sound when it comes close to me, and there will be a decrease in that sound when it moves away from me, away from us. Okay, when we stand near any passing train, the train whistle initially increases and then it will decreases. Yes, this is known as a Doppler effect, named after Christian Doppler. He demonstrated that how the frequencies of that sound increases or how the frequency of the sound decreases. Okay, we will discuss later what is how the sound increases or decreases whenever observer moving or sound source is moving. Okay, right. So Doppler effect means the phenomenon of apparent change. Apparent change in frequency. Okay, of the sound heard by the listener due to relative motion between source and observer or listener. Okay, so there will be a apparent change in the frequency because of there is a relative motion between this source and observer. So this effect is known as the Doppler effect. Okay. What is mean by Doppler shift here? The difference between apparent frequency of the sound heard by the observer and the actual frequency of the sound produced by the sound source. It is called Doppler shift. For example, here observer standing here, some vehicle approaching approaching him. So he listening some amount of sound. It has some frequency. Yes, some X. But this X is not same as the frequency of the sound source, because that source producing a sound which has some frequency. Whenever it moves towards us or away from us, there will be a apparent change in the frequency because of relative motion. So this is known as a Doppler shift. The difference between the apparent frequency of the sound heard by me and actual frequency sound produced by the sound source. It is called as Doppler effect. Okay, so this is known as Doppler effect, and this is known as Doppler shift. Okay, heights. So suppose a source produces sound with some frequency. We'll call it as a source frequency. Okay, we call it as a source frequency. Some in some book uh, F yes denoted. Okay, in some book new yes. Okay, this is a frequency, source frequency. Sound produced by the sound source, that is source. It has a some frequency, nu yes. Suppose source and observer fixed at some distance. Okay, if the source and observer are at a fixed distance, then the observer observe the sound with a frequency nu naught. Because source is at rest, observer also at rest. So he hear the sound with some frequency, that frequency denoted by mu naught. And you may know that, sir, mu naught is equal to mu s. Yes, correct. Whenever the two, the source and object or observer is at rest, there will be a frequency nu naught equal to nu s. Nu s is nothing but source frequency. Nu naught is the observer listening frequency. Okay, observe the frequency. But at rest, this is a condition. Because here, no source is moving or no observer moving towards the source or away from the source. So here, there is no Doppler effect. Okay, here there is no Doppler effect means because there is no difference in frequency. Yes, there is no frequency. There is no change in frequency. There is no apparent frequency. Same sound source is something frequency like 500 hertz. Observer also observe that 500 hertz. So there is no apparent change in that frequency. That is no Doppler effect is observed. But if either source or an observer both move, okay, either source move or observer move or both move. So in that case, V naught is not equal to Vs because there is a change. That is when the source and the observer are in relative motion with respect to each other. Okay, with respect to each other to the medium in which sound propagates, and the frequency of the sound wave observed is different from the source frequency. Okay, source frequency, because there is a relative motion between them. This phenomenon is called Doppler effect. The frequency perceived by the observer is known as the apparent frequency. Okay, not at rest. Some moving, maybe source moving or observer moving. In that case, the frequency observed by the observer is known as the apparent frequency. Okay, so these are all the keywords: apparent frequency, source frequency, and source frequency, source observer, where there is a no Doppler effect, and when there is a Doppler effect happens, all keywords. Okay. Source and observer. We can consider either the source move or observer move or both in motion. Further, we can treat that motion to be along the line joining the source and the observer or incline at angle, some angle. Okay. So source and observer moving in a straight line or some angle. Okay. But for simplified form, simply in the simple terms, we have to find only in that single line. Okay. Right. Medium. Medium means here. Yes. Medium means air. Okay, whatever medium, but for the simplified term, we have to take that air. Okay. And the speed of sound. We can also consider the case the speed of source or observer is greater or lesser than the speed of sound. Already we know that something speed of the sound in that some other free temperature. Yes, for 0 degree temperature, there is a sound of sorry speed of sound in something value, and suppose temperature increases, the speed of sound increases or decreases with respect to that weather condition. Okay, so sound has a speed with respect to medium. Okay, so you have to know what are the terms or keywords in here. Okay, first of all, we will be discussing about that source in motion and observer at rest. Okay, this is a first case. Source in motion and observer at rest. So here also means source moves towards observer one. Source moves away from the observer two. Okay, there will be a two subdivision here. Okay, for this source in motion means so maybe source in motion with respect to observe towards us or away from us. Okay, later we will discuss that observer in motion and sources later. Okay, first of all, consider source. Yes. Okay, source means sound producing device. Okay, right. So consider sound source. Yes, which is moving with constant velocity. Okay, velocity. Here V means velocity. Okay, right. Vs means because in our physics book there will be a something similar symbol V, capital V, volt, like this V, velocity. This is new. Already I told you for the frequency. Okay, this is new. This is V. This is volt. So that only that's why I am putting here something velocity. Okay, right. So consider source. It has it is moving with a constant velocity vs by emitting sound. Okay, so sound has frequency. It emits a sound. It has a frequency. Frequency means n. Here in your book n denoted by the frequency. Okay, so that's why I am putting n here. Source, it moves with a vs constant velocity and it produces a sound. It that sound has a frequency n. Observer at one end at rest. Here O means observer is at rest, stationary in the frame of reference. Okay, in which the medium also at rest. Okay, let the speed of sound wave of angular frequency, because angular frequency omega, this is a angular frequency of the sound wave, because angular frequency means sound waves produced like, yes, so it has an angular frequency. Whenever an object moves in that circular motion, it has a angular speed. Okay, so angular frequency and time period. T naught. The speed of the wave of angular frequency omega, we can take as omega, and its time period T naught, both measured by this observer. Okay, this observer, both measured by the observer. Oh, okay, omega T naught, both are at rest. Okay, so assume that observer has a detector. Detector is a device which is used to detect the counting. Okay, so he has a detector that counts every time a wave crest reaches us. Already you know that crest. Crest means top player, top point. Yeah. So whenever a source is producing a sound, that crest reaches him in that position. So he observed that crest by the detector. Okay. He has a detector. So detector which is used to count the crest. Okay, right. As so we have to draw one symbol figure, symbol diagram now. So here is observer S1, S2. So observer and source at first position. So distance between them, capital L. Capital L means distance between the observer and the source. So this source moves with a velocity, so Vs. So from this position to this position, towards this position. Okay. After some time, it will come into this position, S2. Okay. So here, Vs, T naught. And the total distance, L plus Vs T naught. Okay. So what is Vs T naught here? That means already we know that the formula for velocity. Velocity means distance by time. Yeah. Distance by time means velocity. So suppose distance by time equal to velocity. V. Suppose we want to know the what is distance. So distance means velocity in time. Okay. So if we want to know what is time, distance by velocity. So these are the three terms. Okay. V velocity is equal to or speed is equal to distance by time. Velocity means displacement by time. I think issue. Okay. So suppose if you want a distance, we have to multiply that speed into time or velocity in time. So V into T is equal to D. Suppose we have to know what is time. So we have to divide distance by velocity here, right? So for this position and for this position, we have to find distance. So I don't know what is the distance between these two positions. So I will multiply velocity, that is Vs, source velocity, into time period. T naught. Already I told you what is T naught. T naught be the time period measured by the observer of that sound source. So T naught be the time period of the source measured by the observer. Okay, clear? Right. Okay, right. So as shown in the figure, at times equal to T naught. What is meaning by T is equal to 0? That means T is equal to 0 is at initial position, initial time. Okay, initial time. So initial time times is 0. So source is at rest here. So at times equal to 0, source is at S1. Okay, clear? After some time, that source move into that some other position. Okay. So source which is at distance L from the observer. Okay, right. Who is listening here? Okay, he listening that siren sound. Okay. This source emit crest because this source emits sound. Yes, correct. Source emit sound. So emit crest. This crest reaches the observer at time t1. So t1 means already I told you time is nothing but distance by velocity. So distance here L by velocity Vs. Okay. So L by Vs means the distance by velocity. So already that in your book you have to know what is uh, some other quantity that is L T1 V T naught. Okay, right. So the source. Okay, sorry. Here V only because source is not moving. Vs means source is moving. Okay, here source is at rest. So source is so we have to put a V only. So not a Vs. Vs means already I told you moving velocity. So V. Okay, because observer count that time period, angular frequency, and the speed of the sound wave. So speed of the sound waves here V because source is at rest. Whenever sound moves, that velocity changes. Okay, then only you have to put subscript yes. Now we have to put only V. Okay, right. You clear. So T1 equal to L by B. Distance by velocity equal to time period. This time period means that source emit a crest. This crest takes some time to reach the observer here. Okay, right. Okay. After some time means T is equal to T naught. Already I told you T naught means that is a time period of the sound wave observed by the uh, man. Okay, right. So at time T is equal to T naught. That means source moved a distance, some distance. Okay. So at times equal to T naught, the source has moved something distance. So how to find that distance means already I told you here because at times equal to t is equal to 0, source is at here. After some time t naught, it will go into the here, so it crosses some distance L2, L3 or whatever. But what is the distance between these 2 points? Already told you velocity in time is equal to distance. So velocity means the source moving velocity. Time period means already that's observed by the time. So observed by the man. Okay, right. So T is equal to T naught at a time. Okay, the source has distance traveled traveled distance. Yeah, Vs T naught. Now that source reaching this position S2. So from this observer, S2 is at rest, is at position L plus this distance. This is also distance. This is also distance. So after reaching this position, the distance between O observer and S2 means L plus Vs plus T naught, Vs dot T naught. Okay. So this is the total distance between these 2 points, right, from the observer. Okay. And also at S2, sound produces as well as emit sound. It has a crest. Okay. This is called a second crest, and this will reaches the observer by taking the some other time. Okay. So at S2, the source emits a sound, that is second crest, and this reaches the observer at a time t2. Already we have a t1 L by B. Now we have to find what is t2. T2 means the source produces second crest. This crest takes a time t2 to reach the observer. How to find that t2? T2. So this is a time between the S2 and observer. So first of all, you have to um, add that first time T naught. Yes, right. And then add that L plus Vs T naught by V. This is also time. Yeah, because this is the distance. L S1 observer S2. So this is a Vs T naught. So total means L plus Vs T naught. Okay. So this source has a velocity V at rest. Suppose moving, it has a velocity Vs. Okay. Right. Because this V means the sound produces a the source produces sound which has a something speed with respect to medium. Suppose this medium, this source moving some other position, that velocity will change. So Vs V, right? So T2 means two addition of two time period. One is T naught, another one is total time period. Okay, so L by Vs by T naught by is its velocity. So that only we can put T2 is equal to this. Okay, and already we know that frequency with respect to time. Frequency with respect to time means this is the formula. N is equal to 1 by T. In general, N is equal to 1 by T. What is the meaning here? Frequency, here time rate. The number of vibration or number of oscillation or number of cycle per second means frequency. Okay. Number of vibration or number of oscillation per second means vibration. Frequency. Okay. Right. So N is equal to 1 by T. This is a general term. So suppose N into T means 1. Yeah. T goes here and multiply with N, and N into T is equal to 1. This is one cycle or one vibration. N into T. Frequency into time. Okay. Suppose for that counting that N number of cycle or N number of vibration, we have to label it as some other term. So N1, N naught, some other. Okay, right. So frequency N, time period here T naught. This is a one quantity which denotes that how many vibrations, in our case, how many crusts. Okay, right? You may clear that. Right. So at time N into T naught means we have to find how many vibration or how many crust in this case. So source produces its n plus 1 crust at time is equal to t1, source is at rest s1. At times go to t2, source is at some other position s2. In that position the sound source produces second crust. Yeah, but in terms of n in t, there will be a many number of vibrations or many number of crust. So that source produces n plus 1 the crust, and it reaches the observer at a time. So in that case, for the n plus 1 crust, for the n plus 1th crust produced by the sound source, it reaches the observer. It takes some time. So that time denoted by n t n plus 1. Okay, t n plus 1. Already we know that what is t2 and what is t1. Okay, so t n plus 1 equal to, we have to multiply n t naught plus l. Here also we have to multiply n. So here l, here n. Okay, n vs t naught by v, because we have to multiply n into that time only, not the distance. Okay, so that only that's why I'm putting n here and n here. Okay, we have to multiply for the time interval n t naught. Already written it. Okay, so n t naught l plus n t naught into vs, so n vs t naught by v, this v l. For the n plus 1 crust, we have to put n. So n t naught becomes as n t naught, vs t naught becomes as n vs t naught. Okay. So for the time interval between these two time interval, because this is a past crust and this is the n plus 1 crust. So we have to find the time interval between these quantity. The director with the observer counts n crust, because n plus 1 minus n 1. Yeah, n plus 1 minus 1 n. Yeah, correct. So we will calculate what uh, crust, what are the naming of crust, first crust or second crust or nth crust. Okay, so t plus 1 minus 1, which gives n. N means n crust, because this is a first crust, this is n plus 1 crust. Whenever we subtract these two quantity, we got that we will get that n crust, and the observer records that n crust and finding the period of the wave, which is denoted as t, which is he denoted as t. So t means that observer record that period of the wave n plus 1 and first wave time interval between that. Okay, right. So t n plus 1 minus t1 by, we have to divide by n, because frequency is equal to 1 by t or t is equal to 1 by n. Time period is equal to number of vibrations by frequency. So here one general time, but in this case, we have to find the time interval between these two, because it gives a number of crusts. We don't know how many crusts. Something one man counting that 10 crusts, some other man counting that 12 crusts. So we have to put only t n plus 1 and t minus 1, which gives the number of crusts. So number of crust by frequency, which gives time period. Okay. t n plus 1. Already we got a t formula for equation for t n plus 1. nt naught L plus n Vs T naught by V. Okay. And what is that value of T1 L by V? So you have to subtract L by V. Okay. So now this V belongs to these two quantity. So we will written as like this. Okay. These two quantity same. So L by V minus L by V. So cancel each other. NT naught plus NVST naught by V by N. Okay. And this N belongs to this both this quantity. So we have separate these two quantities like this. Okay. So N T naught by N, NN cancel out. N by N, so cancel out. So we got T naught plus Vs by Vs into T naught by V, which is equal to T. This is a time period of that N plus N crust. T is equal to T naught plus Vs T naught by V. We can take an T naught as a common. Okay. So now 1 plus T, sorry, 1 plus Vs by V because T naught taken as a common. So T is equal to T naught into 1 plus Vs by V. But T is nothing but because already I told you T naught means 1 by N. Yeah, because T is equal to 1 by N. So here we can label it as T naught. So T naught means 1 by N. The concept is not changing. Okay. So T is the time period, N is the frequency. Time period is equal to 1 by N, 1 by frequency. So T naught here. But 1 by N dash means we have to label it as T. Okay. This is T naught, this is T. This is initial condition. This is some other time for the nth crust. Okay. So T is equal to 1 by N dash. T naught is equal to 1 by N. So we have to put that is 1 by N dash 1 by N here. So T becomes 1 by N dash. Okay. T becomes 1 by N. Okay, right. Suppose if we want N dash means we have to reciprocal this quantity because 1 by N dash becomes N dash means reciprocal this quantity. So 1 by N becomes N. Yeah. This quantity reciprocal means 1 plus Vs by V power minus 1. Power minus 1 means reciprocal of that quantity. Okay. So N dash equal to N into 1 plus Vs by V whole power minus 1. Here, suppose we can take an as a one condition, that is Vs source frequency is less than that sound frequency. Sorry, sound speed of sound. Source sound is very less than the speed of the sound means in that bracket we have to convert into according to the binomial theorem. Okay. So then becomes as 1 plus Vs by V. So minus 1 goes here because Vs is very much less than this quantity. So minus 1 goes here according to the binomial theorem. So 1 minus Vs by V. Okay, right. So apparent frequency of the sound as heard by the observer is n dash equal to n into 1 minus Vs by V. This is a apparent frequency. N dash means apparent frequency. N means original frequency. Already I told you source frequency. So apparent frequency means original frequency into some one quantity, some one quantity. That means 1 minus Vs by V. Okay. Suppose if the source is approaching the stationary observer, here source is moving away from the observer. Suppose source is moving there towards observer. So which is moving towards him. Okay. So what is the formula for apparent frequency? Already we have derived n dash n 1 minus Vs by V. But in that condition, Vs means source speed. Okay. Sound speed of sound and source sound. Okay. But in that case, source is towards him. So we have to put minus Vs. Okay. Because in the opposite direction. In previous case, source is moving away from him. Okay. So plus Vs. Now source is moving towards him. So we have to put minus sign. Minus sign means opposite direction. So 1 minus of Vs by V. So minus into minus plus. So this will become as n dash equal to n into 1 plus Vs by V. This is a apparent frequency whenever observer rest and that source is moving towards or approaching towards him, towards the observer. The apparent frequency calculated by this formula. Here plus sign. Suppose away from the S, minus is there. Okay, this is a case for source in motion and observer at rest. Okay, now we will go into that another case. Another case. Observer in motion, source is at rest. Okay. So second case, observer. Okay, now observer at rest. Sorry. So observer at motion. No. Okay. Observe motion. Source at rest. So here observer. Here source. Yes. So we don't need to put it S1 or S2 because source is touched. So we simply label it as yes. But observer, we can label it as 1, 2, 3. Okay. So this is a observer at position 1. After some time, observer moves here. So this is observer at position O2. Right. Okay. Source is at rest means there is no velocity for the source. So Vs equal to 0. Okay. So Vs is equal to 0 means source is at rest. And the distance between the first observer position to the source at the fixed position, capital L. Already we know that. Okay. This observer moves with a velocity. That velocity denoted as V naught. Velocity, observer velocity, so V naught. In last previous case, we have to we put it that Vs. So now we are putting V naught for the observer. Okay, right. source is here, observer is here. He moves towards this position. So he moves with a one velocity, some velocity. So V naught, O naught here, and suppose sound wave, the velocity of the sound waves, V plus V naught. This is the velocity of the sound wave. Okay, because source producing sound here, observer moving here. So he moves with a velocity, and sound produce coming with velocity v in that direction. Whenever to velocity in opposite direction, we have to add. Already you may studied in the 11th class. Yeah, relative velocity between two objects. Yeah, one A car or B car, and moving parallel to each other. Velocity, what is the relative velocity, and moving towards opposite in direction, and what is the relative? Already you may know that. So by this relative velocity equation, observer moving with velocity and source moving with velocity v. So we have to add v plus v naught in this direction. Okay, right, right. So consider an observer is who is moving with a constant velocity v naught towards stationary source. This source producing a sound emitting which has a frequency n. N means frequency of the sound wave. Right. The time interval between the arrival of the first and n plus 1th crust. Already we have discussed. Yeah. For that time interval, we have to subtract the first crust time interval for first crust and the n plus 1 crust. So that same case also applies here. So the time interval between that arrival of the first, because the source producing a sound, so observe moving here. So he approaches the some one crust, and some other time he bombarded with that another one crust, that is maybe n plus 1 crust. Okay. So the time interval between the arrival of the first crust and n plus 1 crust means Tn1 minus T1. Already we know that. Yeah. So Tn plus 1 means here n into T naught minus T1. T1 is initial crust or first crust. Yeah. So we have to put that quantity in the reverse order by like this. Okay. Okay. So this is a time period of the wave, time interval between the first and n plus crystal. So the time period of the waves as measured by the observer t. So t is equal to tn plus 1 minus t1. Okay. So n t naught minus n v naught by t v naught t by v plus v by n, because we have to know what is time interval. This is a time interval. This is a time period. So time period means 1 by n. So time period by time interval by frequency n. Okay, right. So this n belongs to this fourth quantity. So we have to separate by like this. So n cancel out. N cancel out. Okay. So then this equation becomes as T naught minus V naught T naught by V naught plus V. as well as with the last case, we can taken as T naught as a constant. So like this. Okay. So this is a apparent frequency, apparent time period. So apparent frequency means we have to put T is equal to 1 by N and T naught is equal to 1 by N. This is 1 by N dash. This is 1 by N. Okay. So T is equal becomes as T 1 by N dash. T naught becomes as 1 by N. 1 minus V naught by V naught plus V. Right. So we can simplify it also this quantity because V naught plus V here. So this goes into here. So multiply with 1. So this will become as V naught plus V minus V naught by V. Yeah. So V naught and V naught cancel out. Okay. So once again. Sorry, sorry. Okay, right. Now clear. So this quantity hovers into here, 1 into V naught plus V minus V naught. So divide by V naught plus V. So V naught cancel because same quantity. So only V is there. So 1 by N into V by V naught plus V. This is a frequency. Suppose if we want a reciprocal, N dash, N, and this becomes as minus 1. I told you. Or you can reciprocal this quantity. This is the apparent frequency of the sound wave as heard by the observer in this case. Okay. Suppose observe another one case, observer is moving away from the source. We have to put that minus n here. Okay. So because V naught away from us, so V naught becomes as minus because opposite direction. So minus V naught. V naught becomes as minus V naught. So in that case, away from that source, so V naught replaced by the minus V naught. Okay. Okay. So observer moves towards source. Observer is there and the source is there. Observer moves towards S with some velocity V naught and the source is at rest. The velocity of the sound waves produced by the sound source is V. Velocity of the sound waves produced by the source is V. V naught means observer velocity, source velocity means Vs. So whenever source and like sound speed wave, speed of sound wave is in the opposite direction, we have to add them. Okay. So V equal V plus V naught means source and sound waves in opposite direction. In the same direction means we have to replace the V naught by minus V naught. Okay, this is a case for observing motion and the source at rest. Right. So now we can see that one simulation related to this topic. I can show you. So, so now you can see one source is moving towards one observer, front observer, and back observer. When the source of sound waves is moving related to the observer who is hearing the wave, there is a shift in apparent frequency. Yeah, here by the observer. Look at the animation. Right. This animation shows that the sound waves moving at the speed of sound. Okay, whenever the source producing the sound and sound has some speed and the source has some speed. Whenever sound source moving at the speed of sound, that diagram shows that sonic boom. Okay. So now you can also hear boom, boom. Okay. So sonic boom means when the sound source is traveling faster than the speed of sound, a cone of constructive interference trails behind the source. At the moment when the edge of the cone crosses the path of the observer, a loud sonic boom is here. Okay. So whenever sound source traveling faster than that speed of sound, a cone of constructive interference happens. That phenomena is called as sonic boom. Okay. Like, okay. So now we will do that symbol animation simulation. So first of all, both are rest. Okay. So source at rest. Observer at rest. Okay. Stop. So source producing a sound. Observer is at rest. Okay. Right. So source frequency, already told you, Vs 343 Hz. Perceived frequency as well as, because both are rest, so V naught equal to Vs. Yeah. You can remember that. V naught or nu naught. Okay. N naught already. So in terms of frequency, we don't say that V naught, nu naught. Okay. So nu naught equal to nu, or N naught equal to N, Ns, or F naught equal to Fs. Okay. So source frequency which is equal to perceived frequency. So 343 Hz, 343 Hz. And speed of sound 343. Already you know that the speed of sound in that medium 343 and 20 degrees Celsius. Suppose temperature changes, speed of sound also changes. Okay. The source wavelength 1 meter, but wavelength is not important factor in our book. Okay, because in terms of other board syllabus, wavelength also included, but in our syllabus, wavelength is not important factor. Only frequency is important factor. Okay, so observer rest, source at rest. Now, second case, source in motion, observer at rest. So source in motion. So source moves, source frequency as well as 344 Hz, but perceived frequency 368.81 Hz. The speed of sound does not change, 343 meter per second. The source moving towards us. Okay. You can calculate the how the perceived frequency by that our formula n dash, that is apparent frequency. Yes, n dash is equal to how the formula will decide that perceived frequency here. So source is approaching 368.81 Hz perceived frequency. After that, suppose that source passes us, the perceived frequency changes. You can note it down. 320 by 57 Hz. Yeah, because source is moving away from us. So here now perceived frequency less than that source frequency. Yeah, correct. Okay, right. So you can remember that n dash equal to n into 1 plus bs, sorry, nu s by nu by into quantity, that is speed of sound, speed of like speed of sound and source frequency, source sound. Okay, right. In another case, observe in motion, source is rest. Okay. So observer in motion, source is rest. Source zero velocity, observer some other velocity are moving towards or away from this. Okay, so I can take it as a minus 37 meter per second. So source, let's start. Source is rest, observer moving towards that source. Source frequency 344, 43 hertz. Pursued frequency 380 hertz. Because n dash equal to n into v by v naught plus v. Okay, we can reciprocal. So minus 1 is that. So 380 hertz. Once observer reaches the source and passing that source, frequency decreases. You can note that down. Yes, pursued frequency 306 hertz. Now, clear all with your Doppler effects. Yes? Okay. So let's finish our class. Please recall your Doppler effects syllabus in our book and take that important formula and the times, keywords, etc. Okay. Finish. I will finish. Jai Hind, Jai Bharat, Jai Vidyashakti. Thank you.